Now, sometimes after calculating your slope, you may be required to calculate the error in slope. Now, error in slope has a formula, and mathematically we have that error in slope equals 4w over nr, where w is known as the vertical scatter and n is known as the number of plotted points, and then r is our horizontal range. So we need to know each of these values before we can calculate our error in slope for this graph. So how do we go about that? W is the vertical scatter, n is the number of plotted points, r is the horizontal range. So how do we get horizontal range? Let's start first with the horizontal range. Now, horizontal range, to get the horizontal range, you just go back to the horizontal axis from your table of values. This is the vertical axis, this is the horizontal axis. So to get the horizontal range, we simply say the highest value on our horizontal axis minus the least value on our horizontal axis. So simply say 4.3 minus 0.9. That will give you horizontal range. So say 4.3, all right, 0 minus 0.90. So our horizontal range here automatically becomes, that will give us 3.40, or you can simply say 3.4. All right, so like I said, go to your horizontal axis on your table of values, look for the highest value and look for the least value. The highest value minus the least value on the horizontal axis will give you the horizontal range. So we can simply put it here, we can say it's in cm, or we'll just leave it that way, 3.40. That's our r. Now, our number of plotted points, n is the number of plotted points. How many plotted points do we have on this graph? We have 1, 2, 3, 4, 5, 6. So our n will be equal to 6. Now the next one here is w, vertical scatter. So how do we get vertical scatter? Now it's very easy to get the vertical scatter of the graph. You go back to the graph, look for the highest point or the farthest point above the line of best fit. This is our line of best fit. We look for the farthest point above the line of best fit and the farthest point below the line of best fit. This is your line of best fit. Farthest point above the line of best fit, farthest point below the line of best fit. Now looking at our line of best fit, let's consider the points above the line first. Now above the line we have this point and this point. Alright, between this point and this point you can see that this one is farther from the line compared to this one here. So this is the farthest point above the line. So what do we do to it? We simply draw a straight parallel line through the farthest point above the line. Through the farthest point above the line. A straight parallel line through the farthest point above the line. Now, what do we do to the point below the line of best fit? The same thing. You draw a straight parallel line through the point below the line of best fit. So now let's do that quickly. Alright, so this is what it's going to look like. A straight parallel line through the farthest point above the line of best fit, a straight parallel line through the farthest point below the line of best fit. Okay, straight parallel line. So this is what it's going to look like. We draw a straight parallel line through the farthest point above the line of best fit and a straight parallel line through the farthest point below the line of best fit. So this is what we have. Now those two parallel lines, the one above the line of best fit and the one below the line of best fit, should be broken lines. Now to get our vertical scatter W, we simply draw a straight line, okay, touching the point above the line of best fit and touching a point on the line above line of best fit, and touching a point on the line below the line of best fit. Alright, so this is the line touching the farthest point. This is the line touching the line above line of best fit, and this is touching the line below line of best fit. So this is what we have here. So how do we get W? To get W, you simply trace it to your vertical axis. Alright, the highest value here, or the top of the line here, you trace it down to the vertical axis. Now this is 350, this is 400. Now remember, each thin line here is 10. So if this 400, here is going to be 390, and here is going to be 350. So our W is going to be 390 minus 350. So that will give us W to be equal to 40. Now to get the error in slope, we'll come back again to our formula. It says error in slope equals 4W. We have W to be 40. That's 4 times 40 divided by NR. Remember, N is our number of plotted points, which we got to be 6. So we have 6 times R being the horizontal range, which we calculated to be 3.4. So answer here is going to give us 4 times 40, which is 160, divided by 6 times 3.4, which is 20.4. So we have 160 divided by 20.4, which is 7.84. So the error in slope here, using our formula, is simply 7.84. So write this as plus or minus 7.84.